Hello and welcome to this recording for SOLIDWORKS PCB Connector for Altium Designer. So the PCB connector is something that sits directly within Altium. So on the right hand side here you can see I've got my panel showing. Before you get the option to show that panel though, you need to make sure that the software is installed. And in the later versions of Altium, that's done within extensions and updates, accessed through the top right hand corner. And within here, as long as you're connected to the internet, you can go in and install the PCB connector. And there'll be ones for different versions of SOLIDWORKS, one for 18, 19 and 20 as well. So the idea would be that you'd pick the same connector to match your mechanical license type. Okay, so to get the panel showing initially, you need to go in and view your panels, and you should find that you've got a SOLIDWORKS PCB connector visible. That enables the right hand side to be seen. And the connector works best when you're really starting off with a board design. So I haven't got any components yet. I'm looking at shaping the board, and I want to make sure that this all fits nice and neatly within an enclosure within SOLIDWORKS. So if I open up a enclosure, okay, this is what I want the board to fit within, and make sure all the components don't clash with any of the sides of the mold. So I can pull the board from a server. So on the Altium side, I've pushed it to a server which is hosting something called PCB services. I can then pull the same project within SOLIDWORKS, so connecting to that same server to pull in the design. And I'm just going to choose to save the assembly file for this board. So it builds a native assembly, and when I get to the point of adding some parts to the board, they will be built as standard SOLIDWORKS native parts as well. Okay, so I've got my board, I've got one configuration. If I had multiple variants on the Altium board, I'd see those as separate configurations. But for the moment, you can see I've got the project name, which could be called anything, and then the board file here. So first of all, let's reshape this within the main top level assembly. So using normal SOLIDWORKS tools, I can just pull in the board and add a simple mate to put that into position. And I can see that actually it's not going to fit quite clearly, so I can go in and make an alteration to the sketch and then reshape it so it does fit. So the normal workflow here would be to go round and pick the edges of the board and to offset them to give you the new bounds that you need. Create the enclosed shape and then push that back to the guys within Altium. Here though, I'm going to cheat a little bit. I've got a pre-offset sketch that I'm simply going to convert in and make use of, but it could be sketched using any of the tools within SOLIDWORKS. So it does support complex shapes. It doesn't have to just be a rectangle or a circle or a basic shape. It could be anything, and it's much easier to add things like tangency between lines and arcs than it would be with any ECAD package. So I'm confident that fits. So now I can go in and push that back to my Altium colleague. And this is where the workflow gets really, really good. So rather than doing any sort of export to STEP or DWG and having to manage those files, I can just pop back into Altium, which could be in a different PC, and it sees the changes straight away. It's synchronizing the update. There's a preview, so it shows me very clearly what's changing, and I can choose as the ECAD user now whether I want to accept that, or if I don't tick it, if I want to reject it and perhaps do another change back again. Or perhaps I could accept it, maybe tweak some of the sharper edges and then push that back again. But you have got that mechanism between the two departments, which really speeds up the whole collaboration workflow. Next, I'm going to pull in some changes from my schematic. So I've got quite a simplistic schematic, a few parts there that I'm now going to make use of. And I'd normally start off with the larger components on a board, make sure they fit, and then move on to the smaller components. So let's put the HDMI connector there and the USB on. So you can see here I've got my main 3D model within Altium. Everything on the front, other than the SD card holder which is on the back. Okay, so before I do any copied tracking, I would normally, as I say, work on the larger components and post that back to my mechanical colleague. So again, I'm uploading this to that central server, and my mechanical guy will then pull it in. And again, it sees the changes automatically. It gives me a list of all the things that have changed, so all the components here, as well as all of the layer changes, which by default are decals, so like an image on the board, which is very lightweight, much quicker to build than if you're using a step file and having to build all the separate bits of copper as bodies, as separate parts, which gives you a much larger file as well. So you should find with PCB Connector the workflow is very slick, very quick, and the file size should be a bit smaller as well, but the time it takes to build should be a lot better than what you're used to. Okay, so there you can see the decals showing. Okay, the tree is built, so I've got all of the parts there, and you can see that all of the parts have the correct designators from the Altium side. They do need to be unique, so make sure that the naming conventions you use within Altium are correct, that everything shares a unique name. So moving on then, let's move on back to the top level assembly, and we can move components from here. So let's turn off those decals, and let's say I want to edit my assembly, and I want to just shift either by dragging, perhaps using my triad here, just move that to a more suitable position. We can also do a similar thing from the subassembly, so I could drag maybe this component here, release it, and all of the holes can rebuild and move with the component. Okay, so it saves you having to worry about doing that as a separate step. It's all nice and neatly kept up to date. We can also add cutouts to a board. Okay, so that could just be a manual edit of the board, a standard cut extrude that you draw. Obviously you can add dimension to that. So that's 3 mil. And as I say, do a normal cut extrude for it. It could also be patterned, it could also be a hole wizard, so it's very quick and easy to get all the mounting holes positioned onto the board. We can also run interference checks within the assembly as well, which is a standard SOLIDWORKS feature, to make sure that there's nothing interfering with anything. So here I've designed in a problem here. My LED is actually missing a cutout. Okay, so it very clearly shows me all the volume of interference, so that I can use that information to make a design change to the board. So even if something was clashing just by a fraction of a mil, that would be detected within the interference detection within SOLIDWORKS. So I'm not going to make the cutout change here, although I could do. Instead, I'm going to let my colleague know that I have added a single cut. Please add cutouts to my LEDs, and be aware I've moved a few components. And of course the designator I know from the tree, so I can reference the exact component that I've moved. But to be honest, any ambiguity is removed with the fact that if I go back to Altium, I can see the changes, and it will show me a preview of everything that's altered again on the board. So the cutout, here where that's appearing, if I click CN1 US at the top here, it shows me exactly where it's moving from and to. And that can be seen in the 3D view as well. So it's very obvious what's happening. So equally, my HDMI at the bottom here, you can see is moving as well. I've also got the freedom to choose if I want to accept all of these changes. So if I had one of these components that had to be left where it was, I could fix that, send it back to my mechanical colleagues, and advise them that it is fixed and that they need to perhaps redefine the enclosure around the new components. But now everything's synchronized, everything's up to date and visible. In the latest 20 release as well, we also support rigid flex within the collaboration push-pull. So by that I mean the mechanical guys can build the board, rigid flex, and they can manipulate the angle of any bends that are specified on the board as well, and then push that back. So really good features within the PCB connector. Variant support, cutouts, components, everything pretty much that you see within Altium can be replicated within SOLIDWORKS. No need to export anything, so the whole workflow is vastly improved compared to the step DWG export process. Hope that helps. If you've got any further questions, please get in touch with us at Solid Solutions. Thank you.